All right, so you've seen me take, store, and use pointers to normal free functions. And you might be wondering, can I have a pointer to a member function of a class or a struct? And the answer is yes. It is complicated. It's a lot of bullshit. We almost never have a reason to do it. But for the sake of completeness, I'm going to show it quickly here, only quickly. So let's say we've got a struct foo. It's got a couple of member functions, double plus and triple plus. We want to create a pointer that can point to member functions of this struct. So what we do is similar to the case of normal member functions. Start off with the return value. Then in here, you're going to have the pointer, and you got to put some extra stuff because a pointer to a member function is restricted to the type. So this one, we have to say it's pointer to member functions of type foo. Put a star for pointer, give it a name, pointer to foo func, and then you give the return value or the parameter types in here. And there you go, you have just declared your pointer to a member function of type class or struct type poo that returns an int and takes an int. And then we can do p foo func, and we can make it equal to one of these member functions here. And the way you make it equal to a member function, ampersand, class name, and then member function name. So let's do double plus. So now we have p foo func. It's pointing to double plus of foo. If we want to call it, you might say, hey, I'll just do this, p foo func of, I don't know, 4. There you go. No, compiler's going to say, get in my face that shit. Because think about it for a second. Member functions have to be called on an instance of the class. Where in here are we passing it in? How does it know what instance to call this on? We haven't even created an instance yet. So this is obviously impossible. So what is the real syntax? Well, we create a foo, call it f. Here's how you call a pointer to member function on that foo. You go f dot star, then the pointer to the member function. You put that all in brackets, and then after that you put the parameters again in parentheses. And there you go. You've called your first member function by pointer. Hallelujah. And if we run this, we should get, I think, 11. Yeah, we get 11. 4 times 2 plus 3 is 11. Now, if you have a pointer to foo, you got a foo pointer. That's not going to be good. PF. You can call it like this. PF pointer star p foo func. And pointer, yeah, we're going to make this equal to the address of f. Save that. Run it. And there you go. We're calling a pointer to a member function with a pointer to an object now. Just beautiful syntax, right? You want to use this all the time. No, we never use this bullshit. Forget about it. It's just, it exists, is basically what I want to say here. It exists. Now, what you could do also for fun and games is you could stop that. You could make a std, not a std, whatever I typed there. Just known now. Std function, and you can make it point or hold a pointer to a member function. So how do you do that? Well, for this guy here, it returns an int, and it is going to take an int, but you also have to call it on a instance of the class foo. And when you wrap a member function in std function, what happens is the instance becomes the first parameter to the function. So we would do here foo and then int. So this function will take a foo and an int. It returns an int. We'll call our function func, and we'll set it equal to ampersand foo, and now we'll go triple plus. And this should work. I'm gonna say it probably works, but it's not something I do very often. Func. Now we need an instance of foo, so we'll go foo f. func, we'll pass it f, we'll pass it 4, and it should work. Std cout, and I lost my thing there for some reason. Save that, run it. Please don't, yeah, it worked. See, it works. So you can even wrap pointers to member functions in a function, std function. You just got to remember that the first parameter has to be the instance. That's the this that the member function is going to use as its instance. Could also make it take the foo by reference, doesn't really matter. But this is all just, you know, bullshit that you're probably not going to be using that often. The main thing is the main thing I want to teach you guys today is being able to wrap lambdas in a std function. That's really the moral of this story. Everything else is just extra bullshit. Now, since we're on the topic of the functional library, let's take a look at some of the other dumb bullshit that you can do in here. So I showed you function, and it was good. And let me show you some other stuff that you may not ever use, but it's kind of cool anyways. Bind. Binds one or more arguments to a function object. Now, what this can do is this can actually serve as a kind of a kind of adapter for functions. So this unordered map takes functions that are void, no parameters, right? Let's say we have a function, let's say void theong, and it takes a single parameter, int x. And it's going to std cout x some bullshit. Okay? There we go. Now we want to map something to that function, theong. So we can go theong, and what's going to happen? Compiler ain't going to like it because this one is expecting void nothing, but we're giving it a function that is void int. What can we do? Well, we can use std bind, and we can bind some value to one of those parameters and create a new function that takes 0 parameters. So when we do std bind on theong with, let's say, 69, what we're saying is give me a new function that basically calls theong with the value 69. So that function will now have, it will now take 0 parameters, and it will return what theong returns, which is void. And now it matches this signature, and now we can use it in our map. So if I go BS, no, not FBS, and I run this, there you go. So we have just adapted a function that normally would not fit into our container using bind to bind some constant value to one of the parameters here. All right, so I've shown you how to use bind to adapt one function to another by binding a specific value to one of the first function's parameters. That'll give you a function that takes 0 parameters. What if you want to adapt a function that takes 2 parameters to a function that takes 1 parameter? So for example, I would want to take one of the parameters for my adapted function should be passed on to the original function, and the other parameter should just have, you know, a constant value bound to it. So how would you do this? It's a little weird, but you can do it. So here I've got a function theong, takes 2 ints, returns an int. And I want to wrap it in this std function pointer that takes a single int. So what I'm going to do is I'm going to go f is equal to std bind theong. And here's the thing. So the first parameter of theong, I want to bind that to the first parameter that is passed into f. So to do that, you go std and you go placeholders and you go _1. And that means that the first parameter is going to be forwarded into the first parameter of theong. And the second parameter, I'm just going to bind a constant value to it. Let's go with good old 69. And there you go. Now I have bound and adapted theong into my function object here, and I can go f, and I can call it with 1, Let's do std cout f of 1, and that should give me 70. 69 plus 1 is indeed 70, and there you go. So you can use bind to adapt things and to change the signature, basically. Now, there's one tricky thing about bind that you have to be aware of. So let's say we've got a function theong. It takes an int by reference, it doubles it. So we got a std function. It is going to wrap a void with no parameters. We are going to bind theong, and we're going to bind x to it. Right now, x is equal to 1. We're going to call f 3 times. So we should expect x to double, double, and double. So it should be 2, 4, 8 when we put it out. What is it going to be? It's going to be 1. Why is that? Well, the funny thing about bind is that it is going to copy the thing that you bind or that you pass in here. It's going to copy it. So the reference it gets is not a reference to this x. It is a reference to a copy of this x. So this x remains the same after you call f 3 times. That's no good. Now, if you want to actually reference the thing that you're passing in, you have to wrap it up in a Cid Reference Wrapper. And you can create a reference wrapper by just calling Cid Ref. This function is actually quite important. When you're going to be using the thread library, you also have to pass in reference parameters with a Cid Ref. And there are other uses as well. I might go into them in a separate video. But if you want to bind by reference, you have to wrap in a Cid Ref. And if we do this, then you see we get the 8. So yeah, in the reference page here, we can see that reference wrappers are shown here. Reference wrapper is the type. Ref and cref are helper functions that create reference wrappers. So yeah, this is necessary for bind. It's not necessary for just a standard std function though, in case you're wondering. What else do we got here? We got mem function creates a function object out of a pointer to a member. So this makes life a little easier. So instead of writing this, we can write this, which is a little nicer, but it's just a bit of convenience. Now this bind stuff, this member function stuff, it's interesting, it's fun, but we don't really need it these days, and let me tell you why. You can bind things up, do whatever you want with a lambda function, right? So if I got a functor f void whatever, and let's say I want to bind to a member function of foo. Well, let's create a foo first of all. Foo my foo. All I got to do is capture my foo. We'll capture by reference. And the function that we want to do here takes no parameters. And then in the body of the function, we're just going to call my foo dot, I don't know, double plus. And we'll pass it some kind of value, whatever. And there you go. We have now bound up this call to a member function on an object with a lambda, right? Not too bad. If you wanted to do the same thing with bind, you would have to do something like this. F is equal to std bind. So this is nicer and it's more general, built into the language instead of using something from the standard library. So most people these days prefer just using lambdas for everything. But in case you run into it or whatever, this is what std bind is, and this is sort of how it works. Alright, so I've shown you function, shown you member function. Invoke, it can be useful if you're writing template stuff, but it's not that super useful for us, I don't think. Bind and the placeholders. Std not function allows you to wrap a function, and what it does is it takes the result of that function or that callable object, and it applies the not operator, right? The exclamation point. So it can be useful for certain predicates or something you want to get the complement or whatever, but it's not. I don't use it that often. Then you've got some searchers. These guys can be passed into std search, which is an algorithm, and can have different searching strategies. Reference wrapper, went over that guy, is important if you're going to be using std bind, and also for some other things in threads. And then you've got your operator function objects. And I've used a bunch of these when dealing with algorithms and containers and stuff, like equal to. You saw this guy in the hash tutorial, stuff like greater and less for sorting. But these guys can be used together with the standard library algorithms, and then you don't have to write your own custom predicates with lambdas or whatever. You can just plug these guys in and it works. And that's it. That's everything in this library here. So I've shown you a bunch of stuff. A lot of it's going to be like, Chili, why are you showing me this? I don't understand where we would even use this. But I'm just showing you basically for your reference. The main thing that you have to keep in your head is the ability to use std function to make a container that can hold multiple lambdas. That's really the main skill that we've gained today. And the idea of function pointers, because function pointers are used for things, for example, for interfacing with the Windows API. Sometimes you have to pass in a function pointer as a callback that it will, the API will call your function pointer when it receives a message for processing or something like that. So it's not function pointers. Just bare function pointers are also necessary at certain points. All right, so I missed a spot or two. Let's cover that quickly. We know how to take pointers to normal functions. We know how to take pointers to member functions. How about taking a pointer to a static member function? And it turns out that it's a lot simpler to take a pointer to a static member function than a non-static, because static member functions, they don't operate on any specific instance of a class. So in reality, they're actually pretty much identical to normal global functions. The only difference is little differences in access permissions and syntax, but otherwise under the hood they're identical to normal global functions. So if you want to take a pointer to this dude, you would just say int, and then your pointer name p stafunk. I don't know what I'm gonna name it, doesn't matter. And this one takes an int, and we can just do it like this. So we do the name of our class foo, and then the name of the function do static, and I believe you should probably put an and in front of here, but I'm not sure. Let's put the and and see if it needed. It seems to like it, so I'm going to put it there. And then if I try to call that guy, and let's just, to prove the point, let's put it up here before we even create any instance to show that we don't need no stinking instance. And we can just go p stafunk, and we call it with an int. Let's say we'll put negative 420. And if we run that, we should get 420 out, and then we get 69 out, and there you go. We've done it. So that is how you make a pointer to a static function. Pointer to static function can also point to a normal function. It's the same thing. This type of pointer can be used for static functions and just for normal free functions. But for your good old friend non-static member function, you need to use this syntax right here. It's a little messed up, but it works, I guess. I don't know. Anyways, just wanted to say that. Another thing I wanted to say, in my video, I state that you need std function to wrap up lambdas, and that's generally true, but not always true. So here's a normal function pointer here. I can make a lambda point to that, or I can make that point to a lambda function. So if I make a lambda function that takes an int x, and it will return, I don't know, return x times 3, and put a thing there. And you see the compiler, it don't hate it. The compiler's like, that's fine, you run it, and we get x times 3. So what is the difference here? What, did Chili lie to you? Well, not really. In general, you can't do this, because if you put a capture in here, let's make a I don't know, let's do int b is equal to 4, and then we're going to capture b by reference, and then we're going to go x times b. If you do this, now it's no longer good. Once you start capturing things, a normal function pointer is not going to suffice, and you're going to need to wrap it up in std function. But as long as you're not capturing anything, you can actually use a normal function pointer to point to your Lambda functions. So there's a little bit of information there, could come in handy.